Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to Phil Duffy, VP of Product at BrainCorp, a startup company which develops artificial intelligence systems for robots. BrainCorp's operating system, BrainOS, is installed in thousands of robots worldwide. The types of robots include cleaning robots and retail robots.
My name's Phil Duffy. I am the VP of Products at Brain. I manage the product management group, the program management group, and UX design. I've been with Brain for 6 years, and I was part of the group that really transformed the company from an academic research group working for Qualcomm, looking into the neuromorphic computing space, into a company that's deep into the heart of robotics. I was brought on when the company was 24 PhDs, all working in research. And I was given the task to find a pathway to market and a pathway to commercialization with the intent to move into the robotics industry.
I've heard of BrainOS, BrainCorp, BrainOS, and it's a very interesting company. As we can see on the website homepage, these are the kind of things I've seen: cleaning robots, which I think have a massive, massive market. So tell us a bit about the main products of the company and what markets you target and are succeeding in.
Absolutely. So BrainOS is our product. As you mentioned earlier, it is a software product. Although we are very involved in the hardware engineering required to build the right system for that. But BrainOS is essentially our product. It is a commercial grade system that allows companies to build robots, able to scale robotics companies, and also manage robotics fleets live in the public. So we specialize on building robots, autonomous mobile robots that operate in really complex and dynamic spaces. One of the areas we've had a lot of success in is, empowering robots to operate in retail. A retail environment is very complex. Often when our machines are being used, people are stocking shelves, they're using pallet jacks or forklift trucks, they're dropping pallets in the middle of aisles. A lot of these stores that we work at are 24 hours, so they're open to the public, so absolutely operating at the most critical level of safety. So it's a very complex, dynamic environment. The robot needs to understand there's a lot of change happening and still needs to be able to navigate and perform its tasks. So that's kind of the area we specialize in. We don't build robots ourselves. We partner with either OEM manufacturers of existing manual machines, or we partner with robotics companies that are looking to add our advanced kind of technology to their system. Our initial go-to-market entry strategy was to work with OEM manufacturers in the industrial cleaning space. So as you see on our website, there's a lot of large industrial machines that like Zambonis that clean floors. We have scrubbers. We work with other companies like SoftBank Robotics for vacuums, but we also have a number of products out there that do delivery. We're specializing in the delivery systems for retail at the moment. Taking products from the back of the store out to the front of the store. But we're also adding our technology to companies such as Savioke that allows them to, augment their existing system. So that's kind of BrainCorp. It's BrainOS is an alternative to ROS. It is as I said, a fully commercial system that is safety certified for operating in open to the public environments. Some of our OEMs, as I said before, are manufacturers of existing machinery and don't necessarily have the robotics experience required to bring these products to market. So we provide engineering services to help them do that. Other companies, as I mentioned earlier, that have more of a robotics background can take our technology and use it to integrate it into their existing machines. So that's kind of BrainOS's overview. As I said, from a market perspective, we are heavily in the retail industry. We're working on machines that clean floors, machines that vacuum, machines that deliver goods from the back of the store to the retail shelves. And we're also working on technology to scan those shelves that allow resellers to see what's going on there. So, it's a full suite of technologies. And we're having a lot of success at the moment.
Yeah, I've heard a lot about the company. We've published a number of stories about it. Every time we see a press release, we do want to cover it. But I can't remember off the top of my head what kind of numbers we're talking about in terms of, I don't know, how many robots a particular company has ordered or converted. Is there anything you can give us to sort of highlight something?
So we have we've got about 10,000 machines out there that are either been fully automated and deployed, or have been enabled and are on their way to being deployed. So there's about 10,000 machines right now. We believe we have one of the largest fully autonomous fleets worldwide. Certainly, we believe the largest in open to the public environments. Our robots are generally used, as I said earlier, in areas that are more complex, more dynamic. So airports, retail stores, malls, commercial buildings. We have a few products operating in warehouses, industrial settings, but generally our real benefit is in the more complex, open to the public environments.
Right.
Wiz, as you see here, as you just clicked on, that's a product we've developed with our partner SoftBank Robotics. That is deployed heavily in Japan at the moment. Our deployments are both in the US, Japan, and we're just moving into Europe right now. Kind of very exciting time going international. But as I said before, it's not just a technology that allows the development of these machines. We have a technology that has a number of software capabilities in it for manufacture and development of the whole scalable system. So including BrainOS, is a capability to do end-of-line testing, to calibrate your machine during the manufacturing process. There's a number of apps that we've developed to really fine-tune and reduce the errors during manufacturing. And then we have like a much more scalable deployment system. One of our most successful capabilities is the teach and repeat method of training robots. So rather than having to map a whole space, rather than going in and writing code to program, we have developed a very intuitive, easy system that we can train users on, that allows a user to use a machine in manual mode initially, drive the space, and as we're driving it, performing the task in manual mode, we are mapping the whole area, we're creating our routes, and then instantly we can repeat that with our system, so it goes into full autonomous mode. There's no need to do post-mapping, processing. There's nothing to do offline. All this is capabilities that we have on our machines today. So we've got a very scalable system. We've developed specific technologies for deployments that allows us to deploy a brand new machine in about 4 hours or so. And so, not only are we able to, build autonomous robots, but we're also able to manufacture and scale the whole business behind it and deploy them very rapidly.
Right, 4 hours to convert a machine. This is the thing I should ask first. So your system can be attached to an existing floor cleaner, a kind of floor cleaner that's been manufactured for decades. Those floor cleaners that people sit in and drive around and clean the floor. Is that correct?
It is correct, but we don't do field integration. So, the integration happens during the manufacturing process, but without you having to, build a brand new robot from the ground up, we can take machines that exist today and turn them into fully autonomous vehicles during the manufacturing process. And then for deployment, it's a 4-hour process. So again, a lot of companies today in the AMR space, they might take a week, 2 weeks more to deploy a brand new system. They may need to go in, before the robot's deployed, map a whole area, do a lot of post-mapping processing before a machine can be used. We don't need to do that with our system. It's a very intuitive, incredibly scalable solution that allows users that often don't have English as their native language, or potentially haven't even finished high school, to be able to train a robot without us sending engineers into the field. So it's a very, very scalable system that relies on the user having domain knowledge of the space they're in, to set up these machines. And the robotic aspect is incredibly easy for anyone to use and learn.
Yeah, I just want to make absolutely sure I understand it. So I understand the bit where you're saying during the manufacturing process, your system can
Mm-hmm.
be integrated into it. And as I
Yeah.
can, I don't know which page it was, but there was a page that had some nice sort of
Yeah.
pictures on it, which, oh, there we go. So
This is it. Yeah.
that's the kind of system that would be integrated during the manufacturing process.
That is. Yeah.
But what I'm also asking is, say if the machine, it's already made,
Mm-hmm.
can you sort of superimpose the system after the machine has already been made?
No, I mean, we theoretically we could, but we don't. And the reason we don't is because any machine that's already been in use in the field has degradation of motor systems, degradation of wheel bearings, and that all affects how the autonomous vehicle will behave. And so
Right.
really it's about calibration. We calibrate with a brand new machine in the store. We can calibrate in the field as well, but again, if you've got the greatest robotics on the system, but your wheel bearings on the machine are off because it's been used for a couple of years, you're never going to get the level of navigation capabilities that we need, and that for us isn't safe enough. So we insist on integrating our technology during the manufacturing phase, not through field engineering, mainly because the machines we work, I mean, the robotics industry, right? It specializes in dull, dirty and dangerous, environments, and so these machines kind of get beat up in the wild. And so we insist that our technology is integrated during the manufacturing process, as opposed to into machines that have been around for a while.
Right. And although this illustration shows a good number of the components of the
Mm-hmm.
system, I'm not sure if it's all of them, because I'm wondering if, for example, you have monitoring sensors to say if the I don't know, if the wheel's not turning properly, or something
Right.
like that.
So the hardware selection we have is unique to the different vehicles we use. Um, Not every single robot uses the same system, and that's because the hardware selection isn't anything to do with automation. We can navigate on a camera. We don't need anything more than that. But what we look at is the safety requirements for that vehicle. The machine you've got there, it runs at 1,000 pounds, which is several hundred kilograms, and you really don't want that hitting a wall, right? With a machine like that, we look at the speed of the machine, the weight of the machine, the size of the machine. We look at the environment the machine's used in, and the use case. And from that, we decide what the right kind of level of safety requirement is, and we design a hardware system based on those safety requirements. So the machine you have in front of you here is an industrial floor cleaning machine. It's a scrubber. It has a large water tank on it. It has a very different hardware makeup to the Whiz that you saw earlier, the smaller vacuum. But BrainOS is identical. BrainOS is completely hardware agnostic, so it doesn't matter what hardware system is being used. It's agnostic to the hardware.
Right. And just to go back to the bit where you said 10,000 units are out there with
Hmm.
your system integrated into them.
Hmm.
Can you break that, drill that down a little, drill down into it a little bit more to say which companies or how many? Is it all one company? Can't be one company, but give us an idea.
No, 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 no. We work with a whole multitude of different OEMs. So within the industrial floor care space, we have all of the major OEM providers, and there's quite a few. I couldn't tell you the number off the top of my head, 6 or 8, um, but it is all of the major OEMs in the industrial floor care space. We work with SoftBank Robotics, obviously, for the Whiz vacuum system that you've seen. We also work with a number of OEMs in the material handling space. We've announced recently our partnership with Unicarrier and Dane in that area. And then obviously I mentioned the Savioka relationship as well. So no, we work with a whole multitude of different OEMs and robotics companies that use BrainOS technology.
Right, and now, when are when you earlier said that it doesn't take much, robotics expertise to be able to learn how to, operate one of these machines. I kind of wondered if the person who used to drive that vehicle may not have to drive it anymore, but still has to sort of operate it from a
Right.
from a distance
Mm-hmm.
or whatever, however you operate it. Maybe you can explain how it is operated, just briefly summarize it. But also, just out of on a larger sort of question, is it going to mean that a lot of jobs are replaced? If are these machines going to replace a lot of jobs, or what do you think?
Absolutely. No, these are great questions, and always questions that are important to address when we're looking at robotics. So, a couple of things here. One, robots are not as flexible as humans. Humans can do a million different tasks. Robots can do very specific tasks. That's the nature of the business. Robots are good in, as we said earlier, in areas where the task is dull, it's dirty, or it's dangerous. That's where robots really provide the most value. And so, if we look at the retail industry, just as an example of this, we have a janitor that, about 20-25% of his workload is cleaning the floor. But he has a lot of other tasks that he's able to do. The advantage of a robot is the janitor, with his domain knowledge of the space, can set the robot up the way he wants it set up very easily, so it meets all of his requirements. And then now we can save him that time. He can do other tasks. And what's really interesting in today's world with COVID-19 is that janitor now has the time to do the really essential work that's saving lives. The sanitation of surfaces, doors, handles, anything we touch when we go to the retail store can now be sanitized because our robots are freeing up the time to do that, which is very exciting. The other thing that robots do, which is really quite incredible, is we have data for every single process. So we know when the machine's been used, where it's been used. We know the square foot coverage of that machine, and so now not only can companies look at saving time to do the really essential tasks, they can also set compliance levels and say we need our location clean this much, this many square feet, this level of coverage today, and can measure against that. So that's an incredible step up, and also something that's really important during the current crisis. In terms of the janitor and how he works with our machines, yes, the janitor has the initial understanding of the route. He sets the machine up at the start of the shift. He'll clean the machine down at the end of the shift. But he also integrates with the machine by pairing his cell phone to it. So during the shift, the robot's able to send him messages and say, hey, my route's complete, my water's low, I've solved these problems, or you know what, there's an area here I can't get through, it's completely blocked. Can you give me some help? And so there's a full interaction between the robot and the janitor. And what's really interesting is when we talk about, and I'm specifically talking about the retail space here, but this applies to other areas. A janitor on the totem pole of roles in any environment is fairly low generally. But we're seeing a phenomenon now where the janitor has learned how to use our robots, has become somewhat of a robot expert in terms of setting up the environment, understanding the workflow of the machine. And we're introducing secondary robots, robots that are able to scan inventory, robots that are able to deliver goods from the back of the store to the shelves to help restocking. And who is the expert of this robotic system? It's not the IT manager in the store, it's the janitor. And so we're seeing an area now where janitors, initially we provided a tool for them to become more efficient. They become the robotics operator and now the robotics expert in retail stores across the US, which is really quite exciting. So yeah, it's a big change going on. I wouldn't say, we're not replacing a janitor. As I said, the floor cleaning is about 20% of the workload, so we can't replace anyone there. But what we can do is make people more efficient and more productive. And now we're seeing the real fruits of that as janitors are able to operate multiple robots.
Yeah, I'm looking at some of the stories we've covered over the last couple of years about BrainCore. Dane, you mentioned already.
Mm-hmm.
Unicarries also, I think you mentioned, I vaguely remember. Walmart, I just picked out, that
Right.
was this time last year, actually. So you've got to obviously, in robotics terms, that's quite a long established relationship. How old
Yeah,
is
we've been working several years.
yeah, how old is the company anyway, BrainCore?
So BrainCorp is 10 years old. We formed in 2009 initially. The first 5 years, as I said earlier, were research. It was a team of neuroscientists looking at the future of neuromorphic computing for Qualcomm. The
Mm,
CEO of the company is a world-renowned neuroscientist. And so he brought in a number of academics to really look at the future of neuromorphic computing, what's going to happen after Moore's law comes to an end. Is there a next step for linear computing into this distributed system? And during that first 5 years, we really looked at two things. We looked at how the brain learns and how the brain processes vision, because vision's the most intensive thing the brain processes, and how we could simulate that in a computer. And that gave us this visual capability. So at the end of the 5 years, when BrainCorp was looking to commercialize its technology, we realized there was an opportunity here to provide that same system, the learning and the visual recognition, to robotics. And that's when I was brought in. I have background, developing robots previously when I lived in China for many years. And so I was brought in to find a pathway into the robotics industry and a pathway to commercialize our technology. And we really transferred from being an academic company to an engineering company, from an engineering company to a product strategy company. And we're really moving forward and making this happen. So when I first joined, there was 24 people in the company. Now we're close to 400. We've gone through tremendous growth. We're having great success with our customers in the market, but it's a really exciting time for robotics in general and certainly BrainCorp.
yeah, we're very lucky to have started this website. It's a very interesting field, and we're really surprised and very gratified that we're looking at really, good growth over the last few years and hopefully more to come. Certainly not quite
Absolutely.
in the revenue kind of level. You know what websites are like,
Mm-hmm.
it's a very competitive field. Robotics,
Yep.
there's fewer people in there because it's a more difficult field. Not everybody can get into it and just start building robots or writing software or anything. This Dane Technologies, did forget about it, but
Mm-hmm.
now that I'm looking at it, it's jogged my memory that, yeah, it did occur to me that this, I don't know if this is the right picture to have used, but looks like
No.
a different kind of thing to what BrainCore's supplied its OS to before.
Absolutely.
So tell
So
us about this a bit more.
I think the photo you've got there looks like a cart from an IKEA store, if
Mm,
I'm not mistaken. If you go onto our website, I think we have a picture of auto delivery
mm,
somewhere. Let's have a look.
uh,
Yeah, there you go. Auto delivery. Click on that.
yeah, okay.
Yeah, there you go. And so that is it's a delivery system. Um,
Sorry,
no, it's all good. No, it's perfect.
There we go.
Yeah, that's a robot that allows our navigation system again, which we've really fine-tuned for use in dynamic, complex environments, to be able to enable uh, users in a retail environment to stack their shelves quicker and much more functionally easier. So today you've got guys taking goods from a truck when he comes in. The retail stores have a very small back rooms. They don't have a lot of storage. The goal is to have at least amount of product in storage as possible. So when it comes through their supply chain system, from ship to truck to distribution center through to cross-docking distribution, all the way through to the store, it's the minimum amount of time in storage which you're paying for. So product arrives, it's taken off the truck into the back room and then onto the shelves as quickly as possible. And today, you might have 15, 20, 25 people stocking shelves in retail stores, and they are spending a vast amount of time walking from the back room to their shelves, do the stocking, and then walking back, carrying the heaviest carts full of huge goods. There's injuries involved. People are walking miles a day, and so our system allows people to remain at their station at the various different shelving areas they're covering, have a specialist crew in the back room that are unloading the truck, loading up these carts, and our machines are able to take the carts in, drop them at a said location, move back, pick up a new cart, and keep going. And so that's what's really interesting here. We're making the shelf stocking scenario a lot more efficient by using the BrainOS technology.
Which one do you think is going to prove more popular in, say, in a few years' time, out of the two types, the cleaning or the auto delivery one, the material handling one?
You know what? I think they go hand in hand. Absolutely think they go hand in hand. I think we're going to see scenarios with markets that really adopt robotics early. That it's going to be multiple robot systems. Today, robots have been around. Mobile robots have been around for, 10, 15 years in the warehouse and industrial space. We've had AGVs operating for a long time. We're starting to see mobile robots, autonomous mobile robots operating in those areas. But again, it's all closed out in industrial warehouse settings, not open to the public. We're just starting to see the emergence of robotic systems today in open to the public environments. Retail industry has been an absolute early adopter. They're really getting on board. You're seeing robots there that do inventory scanning, robots that clean floors, robots that do delivery. Going forward, we're going to see security robots. We're going to see robots that are able to take goods from store to the curb for pickup. We're going to see a lot more adoption. What's really interesting is all of these different functions require different robots and different specialties that not a single robot company doesn't have. The ability for retail to buy their cleaning machine from Tennant, which is one of the world's leaders of industrial cleaning, buy their delivery system from Dane or from Unicarrier, which are specialists in material handling vehicles. Look at another company for shelf scanning. But the problem with that is you've got to manage all these systems. It's very complex from a corporate level. It's complex to manage the IT, complex to manage security. Where's the data going? The advantage of BrainOS is we can work with all of these different manufacturers of machines with one single system. So all of the robots are operating on the same data pipeline. It's all being stored in the same area. They've got access to a single portal to see how all of their robots are performing and manage their systems. They also have one single encryption system, which is much easier for an IT group to manage. And then there's the familiarity of usage, right? As I said before, a janitor that can clean a floor can now easily operate a delivery system, can easily operate shelf scanning or vacuuming in the carpeted area. So I think you are going to see scenarios going forward when you're going to get multiple use cases of robots, often operating at the same time. And the advantage of having a clear platform approach to robotics is something that customers are really appreciating and adopting quickly.
Yeah, you've answered what would have been my next question about, well, how do you see the future panning out over the next few years? Is there anything you'd like to add about that, or anything that I maybe missed out on asking about that I didn't think of?
Absolutely. The one thing I'd say that's exciting about robotics today, the focus for autonomous robots is on navigation. How do we get from A to B and perform X task in the meantime, right? So the robots today, all of the autonomous behavior is really focused on one single task: cleaning the floor, delivering goods. But going forward, the advantage of robots is they can sense a lot more things than they need to for the task they're performing. So we look at the smart building industry. People have talked about smart buildings for the last decade or so. The issue with smart buildings is that technology can only really be built in during the construction phase. It's expensive to change. It obsoletes within 6 to 10 years, 15 years, and you can't really add that technology to older legacy buildings. But with robots, you've got this whole mobile IoT system that can do a lot of the same sensing, a lot of the detecting that a smart building can. So today we're looking at robots that can clean a floor. Tomorrow we're looking at the same robots that can clean a floor and detect if there's missing goods on the shelves, if pricing is compliant, if planograms are compliant. But we can also look at temperature control. Is the temperature in the store changing? What is the Wi-Fi coverage of an area? Are there any lights out? So you can see how this can be applied to more than retail. You're in the hospital, a robot's driving down a corridor. It's looking at how many lights are out. It's looking at air quality, pollution levels. The ability to add data to mobile IoT is absolutely incredible with robots. But the real secret to it is understanding the value. The IoT industry today measures a lot, and I would argue that not everything they measure is valuable. So it's a case of really working with customers to identify what elements are both valuable and measurable, and how can we increase the ROI, the value of a robot, by adding these like smart technologies to them.
Okay, thank you very much, Phil. I really appreciate your insight.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.